All right, welcome back. We're going to learn how to solve a system of inequalities by graphing. And remember that whenever we graph an inequality, that includes shading. Okay, so we're going to, for each inequality in the system, we're going to sketch the boundary line. So that means identifying the x-intercept, the y-intercept, and maybe the slope. Test an easy point, shade the half of the plane that contains the solutions, and then to identify the solutions of the system, you look for where the inequalities overlap. So you look for where, you have shading from all the pieces. Okay, where the shading overlaps. So let's start off easy and let's work into things that are a little bit more complicated. All right, I'm going to go to my pen here. Remember that when we have an inequality, the boundary line is the equation. So x equals -4. There is no x-intercept. The y-intercept is -4, 0. The slope is 0. And then we're going to test the point 0, 0. And so is 0 greater than -4? That is true. So we're going to go towards. And then for x is less than or equal to 3, we're going to graph the equation. The x-intercept is 3, 0. The y-intercept is none. The slope is undefined. It's a vertical line. And we're going to test 0 less than or equal to 3. That's true, so we're going to go towards. Okay, that's towards. And let's put these on the graph. Here is y is equal to -4, and I need to use a dashed line here. Here I can use a solid. So, and I need to shade towards. Okay, and then I have x is equal to 3. That's this line. It's solid. And then I need to go towards 0, 0, so that's to the left. I'm going to go like this. And then where does all of this overlap? Well, it's going to be, and I'm going to shade it in the highlighter, I'm going to shade it green. It's going to be all in here. This square area right here, above the dotted line and to the left of the red line. Okay? You don't want to do anything where there's just only one color or no color. So this is kind of fun if you use colored pencils. Let's try one that has a little bit of slant to it. Y is greater than 2x minus 4. My x-intercept is 2, 0. My y-intercept is 0, -4. My slope is 2. I'm going to test the point 0, 0. So is 0 greater than -4? That is true. So that gives me towards. So I have 2, 0, and I have 0, -4. And I'm going to use a dashed line for this. And then I'm going to shade. I'm going to shade towards. That's my first line. Now I have an x-intercept of, I think that's -6, 0. And then my y-intercept is 0, 3. My slope is -0.5. So here's 1, 2, 3. If you don't like -6, 0. Actually, that should be +6, 0. not negative. You can use your slope, which would be down 1 over 2, down 1 over 2, down 1 over 2. We go up 1 over 2 this way. Oops. Yeah. And then we will be like this. This would be a solid line, like so. And then I have to shade. So I'm going to, is 0 less than or equal to 3? That's true. So it's toward. So let me shade it like this. Remember, we're looking for where they overlap. Anything that has just one color or no colors, we eliminate. And so my highlighter, I'm going to use yellow. We're in this area here. Right in there. Okay. Next one. This one has a line and a V. All right, a line and a V. So we need to be careful that we get the right stuff going on here. All right. My x-intercept is 3/2, comma 0. My y-intercept is 0, 3. My slope is -2. If I test 0, 0, it's going to be a 0 less than or equal to 3. That's true. And that's going to be towards. So I'm going to go 0, 3. And I'm going to use my slope, which is down 2 over 1, down 2 over 1, down 2. I'm just going to extend it as far as I can. Up 2 over 1. And the reason is so that I can make sure I catch all intersections. Oops. That's going to erase my whole line. And that should be a solid line. We're going to shade towards. So let's just use light blue here. Okay. And now we're going to graph this V. My x coordinate of my vertex. Let's do, I hate it when my pen starts misbehaving. Let's use red. I'm going to set my argument equal to 0. So, and then I'm going to plug it in. So I get y is equal to 0 minus 2, which is -2. So my vertex is the point 0, -2. I'm going to plug in -1, -2, 1, and 2. Plug in -1, I'm going to get -1. Plug in -2, I'm going to get 0. Plug in 1, I'm going to get -1. Plug in 2, I'm going to get 0. And then I'm going to test the point 0, 0. And when I do, I get 0 is greater than or equal to -2. That's true. So we're going to go towards. It's going to be on the inside. Right? So I have 0, -2. This should be a solid line too. And I have this point and this point and this point. I think we're just going to extend this up like this. I can see what my slope is doing. And then here I go here and here. And so my solutions to the absolute value are between. All right? And we're going to look for where we have overlapping, and that's where we're going to shade. That's where our solutions are, where we have both colors. Okay, it's like that. Okay, I'm going to keep going. All right, let's graph this first line. Y equals x plus 5. Let's see, let's pick this. My x-intercept is -5, 0. My y-intercept is 0, 5. My slope is 1, 0 greater than or equal to 5. That's false. So I'm going to shade away. -5, 0, 0, 5. This is going to be a solid line. and I'm going to shade over here. This one, this is going to be 4, 0, and 0, -4. My slope is 1. And then I'm going to test 0 is less than -4. That's false. So I'm going to shade away. And that's going to be over here. And this is a dotted line. So where do my colors overlap? They don't, so I have no solution. Inconsistent. Right? We can wrap these around contextual expressions. Solve the following system. The Rogers are driving across the country. They, both of them together, plan on driving a maximum of 10 hours per day. So whatever Mr. Rogers drives and Mrs. Rogers drives, that has to be less than or equal to 10. That's how I got this expression right here. X is Mr., Mrs., Y is Mr., and I said less than or equal to 10. All right? Then it says Mr. Rogers wants to drive at least 4 hours, so it could be 4, could be more, but no more than 8 hours. So he doesn't want to drive any more than 8, so it could be 8 and less than 8. That's how we got this one right here. Okay? This is Mr. Rogers. Mrs. Rogers can drive between 2 and 5 hours per day. All right? So we have, actually this should be exclusive here. Between should be exclusive. All right? So between 2 and 5. More than 2, less than 5. So let's start graphing this. I'm just going to let each one of these be 1. So this is 10, and this is 10. And my first line that I'm going to draw in red is going to be solid, and it's going to go between those 2 points like that. All right? My second 2 lines are going to be y is equal to 4. 1, 2, 3, 4. I'm going to put that in blue for you. So 1, 2, 3, 4. Here's 4. These are solid. So that one here. And then 8. 8, 5, 6, 7, 8. And here's 8. Okay. All right. So we're going to shade in between these two. And we're going to shade, I'm going to go back to my red for just a second. We want less than, so it's going to have to be in here, right? Remember, we're looking for where everything is overlapping. We have a couple more lines to graph here at 3. Okay, I'm going to put these in purple. This is between 2, x is 2. Here's x is 2. And here's x is 5. And it has to be between these. All right? So where do all 3 of them overlap? That's kind of hard to see, but it's this little like trapezoid spot right in here. Here, here, right in here. And there's the solutions. All right, now this one we have to graph the solutions and then we have to look for the vertices, all right? Then we have to look for the vertices. Remember, vertices are the corners of the triangle, okay? So I'm going to graph each line. So I have 2x minus y is like greater than or equal to -1. My x-intercept is, ooh, wrong thing, -1/2. -1/2, 0. My y-intercept is 0, 1. My slope is 2, negative 2 over negative 1, that's 2. And when I test the point 0, 0, 0 is greater than negative 1, that's true. So that's toward. And then I'm going to, let's do this one in purple. So let's get this one on there. I'm going to do 0, 1, and I'm going to use my slope up 2 over 1, up 2 over 1, up. Again, I'm extending it as far as I can go, just so I make sure that I get all of the, I capture all the intersections. All right, and this one should be solid. And we're going to shade towards 0, 0, so that's going to go this way. Okay. This one, I have an x-intercept of 4, 0, a y-intercept of 0, 4, a slope of negative 1, and if I plug in 0 and 0, I get 0 is less than or equal to 4. That's true. That's toward. So I have 1, 2, 3, 4. Here's this one. This one should also be a solid line. 2, 3, 4. That's this one. This one should also be a solid line, and this one should also be towards. So I'm not going to worry about up in here because I don't have any shading for my other one. So I think I'm all down in this way, right, so far? And then I have x plus 4y is greater than 4. So my x-intercept is 4, 0. My y-intercept is 0, 1. My slope is negative 1/4. And I'm going to shade away because 0 is not greater than 4. And this is also a solid line, and it's going to go here. So, and I have to shade above that. So all of my shading is right in here. Whoops, a daisy. All my shading is right in here, in this little triangle right in here. Okay? Very good. All right, here's our daily assignment we're going to work on in class. If you want to get started and you brought your book home, feel free. Do a couple of them tonight so that you have time to get them all done tomorrow. If you feel like you need more time than 30 minutes, I'll see you tomorrow.